products. We'll go right into the first presentation, which is by Milton Garces and others on surveillance of hazardous volcanic eruptions in Asia. Milton, please, you have the floor.
Just before we will start, good afternoon again. I read for speakers. 3 minutes before your time, I will show like that, and it's to everybody to keep in mind. Thank you.
Thank you. So, first slide will come up any moment. It is, good. So others are our team. So I'm with the University of Hawaii. I'm also with the Palau National Data Center. So we're working together with the Republic of Palau to build the capabilities in the region of interest. We're also collaborating with the Nanyang University in Singapore because they are strategically located in Southeast Asia and they're good folks to work with. Japan National Data Center, also one of our colleagues with a vested interest in the region. Our colleagues in Europe with ARISE, with Elisabeth Blanc is a representative here, who have done some very good work, in particular with the Icelandic eruptions in Italy. The Darwin Volcano Ash Advisory Center in the Australia region. The Comprehensive Nuclear Test Ban Treaty, Pierrick, who may or may not be here, but he's a collaborating partner. And then the Met Service of Singapore is also one of our end user and testers, so both the VAC and Met Service of Singapore. And so this is a Palau National Data Center presentation. And next slide, or do I have control over how to do this? Let's see. Ha! All right. So our aim is to improve coverage, reduce eruption detection latency, and increase confidence in volcanic eruption identification in the Asia-Pacific region. That's our mission statement. The good thing about this project is that we know we can do it right off the bat. The question is how to do it best. So the capability to this, the folks at Sakurajima Volcano Observatory did this before the turn of the century. Then our colleagues in Italy with Maurizio Ripepe have been doing this in Stromboli and Etna also for many years. In around 2004, and bear in mind the IMS was still being built at that time, we did the ASH Ecuador project to monitor volcanic eruptions in Ecuador and Colombia using small aperture acoustic arrays. And so we work specifically with the Volcano Ash Advisory Center in Washington, D.C., and we got a letter from ICAO saying, well done, carry on. Shortly thereafter, the USGS started building infrasound into the arsenal of tools for volcano monitoring. The ARISE project took over shortly thereafter, and they were greatly aided by the Icelandic eruption with the unpronounceable volcano name. I'm sure the guys can do it. And of course, Italy is a lot of active volcanism. And so ARISE is pushed the envelope quite a bit forward and improve coverage in the European region. And so our aim is to now optimize and do something a little different. So the first thing we're going to do is crack down on specifications. So yeah, in some ways, we know we can do this for the big eruptions. Little things are trickier. But the VI, Volcano Explosivity Index eruptions of 4 or more, I'm going to talk more about that on the next slide, we know we can pick that up thousands of kilometers away. So I'm going to use megameters. So VI 4 megameters, that's 4,000 kilometers away. And that's our essentially minimum requirement. We should be able to pick up a VI4 eruption within 4,000 kilometers away. And we're going to design for that. That means that we can pick up bigger ones easily, and that means that we can pick up smaller ones when we're closer by. So it's a scalable type of specification. So I'm calling that V4R4. Now, we're also going to use not just IMS and local regional networks, but start integrating smartphone sensors into the region, because Southeast Asia, some regions have infrastructure challenges, communication and power. And of course, we're going to have to develop new methods to deal with this. So what is the VEI scale? It's not something geophysicists are in love with, but it's something that we have come to accept. It was developed when there's a big eruption, they go out there and measure the amount of material that was erupted, usually by flying with helicopters around volcanoes and measuring the total mass. However, it's become a de facto reference scale, and there are efforts in the community to correlate this VI logarithmic scale with some type of energy estimate. We're going to stick with it because it is the vernacular, and whether something will or will not emerge thereafter, we will see. But VI4 is the eruption level at which you are getting ash into cruising altitudes of aircraft. So we care about airplanes encountering ash at elevation and the economic impact that that might have. And I remind you of Iceland, it being close to this region here. And so now we go a little bit more into the vernacular of the business. There are designated regions, spheres of influence, if you will, for who's responsible for issuing alerts. So you have the Tokyo Volcano Ash Advisory Centers, or VACs. The Darwin has overlap into Asia. And then you also have the Washington, D.C. Volcano Ash Advisory Center, as well as the Wellington. And the Republic of Palau is near the intersection of the Washington, Tokyo, and Darwin Volcano Ash Advisory Centers. So in a sense, it's a good nexus for interacting with all of them. We're going to be working primarily with Darwin and Tokyo VACs because those channels are something that will be useful for us to learn how to navigate. We have worked with the Washington VAC before as part of the Ash Ecuador effort. Hey, Paula, I didn't see you there. And so on the lower left-hand side, it's the IMS network and +1. So IMS plus the station in Singapore, EOS, which has it's an IMS-grade array that will be installed there. And so that provides us an interstation distance of about 1,000 kilometers or so. On a ballpark, it's about 1,000 kilometers per hour is what it takes for sound to propagate to the station. So, which means you might get an alert within an hour, if you're lucky, of an eruptive activity. Well, pilots will prefer to have 5 minutes because you don't want to fly through these things and you want to be able to accommodate the load and the passengers and all these things. So we plan to supplement the legacy systems with the smartphone sensors because we can move them very quickly. And there already is communication. Almost everybody in Southeast Asia has smartphones already because they're more reliable than the copper networks. And so we think that that's something that we could use to fill observational gaps. And so if you missed the panel discussions earlier, anybody who wants to record infrasound can go to the Apple App Store or to the Google Play Store, type the word infrasound and download the app and start recording. And there it is. It's never been easier. So this is our wall of sound. We are the Palau NDC. We are receiving live streams from the IDC. The USA NDC, in collaboration with USGS, already made available streams from the Australian stations, as well as the US stations and the British stations. So Diogo Garcia and the Australian sites are coming in live already through IRIS, and Tim Ahern's here. And this was a collaboration between all of us. So thank you, Tim, and thank you, NDC and the USGS, for making this happen. This is a very wonderful thing for us to have. We still had two more sites, the one in Japan and the one in Papua New Guinea that we are streaming through directly from the IDC. So as a national data center, we have access to it. So all the stations that are pertinent to this project are coming in live now. So onwards. We do have some coverage, and this is an old slide. The Android app came out on Wednesday when I pushed it to the Play Store, and now this is relatively new. And we had to do this. So if you look at this, the slide on the left, these are some of the smartphones that we had. They were all Apple phones in the Southeast Asia and Asia region, and it's very sparse. Why? this is Android land. I mean, the first time we walked into Indonesia and handed somebody an Apple iPhone, they was like, "Oh, what is this sorcery?" They don't use these things. They're prohibitively expensive, so people don't bother with it. It's a luxury item. Whereas Androids is everywhere. So we knew as soon as we landed, it's like, oops. It took us 2 years, but now it's out. So now that allows us to provide coverage in the regions in Southeast Asia, Middle East, Africa, that are more Android ecosystems. And so as you can see on the left-hand side, there's some of our Android ones, and then on the right-hand side, our iOS ones, and here we go. These are some of the volcanoes covered by the IMS and +1 and the Singapore EOS station. There's a lot of volcanoes out there. As you can see, any one of those guys can go at any moment without a moment's notice. And so what you're looking at, those circles there, is about an hour propagation distance. And so in the absence of the Singapore station, it will take a few hours for us to find out where things are. You know, Australia being close, IO6, but then if it happens further down the chain, we might not see things until more than an hour away, assuming all stations are up and the conditions are receptive. So our aim is to populate areas of interest with smartphone networks, or at least smartphone sensors. Because the reality is, when these things are big and loud enough, you can pick it up with just about anything. So the latest VEI4 eruption in the Asia-Pacific region, excluding Russia, which is going off right now, was from Kelut volcano, and in 2014. And the CTBTO reported detections by 14 IMS stations. And so this was a big boy, and this is something that we learned this decade, really. When they're big enough and loud enough, you can pick them up almost anywhere on the planet. If your station is not swamped by noise, they're easy. So the bigger problem is the easier problem than the little eruption one. And the Singapore station at that point was not deployed yet, so we just have a single station detection. But here's the next slide that's important. Our colleague in Chile who is here might be interested in this part. This is the EOS station in an urban environment. We have a lot of noise. Look at the vertical scale on the left-hand side. That's, yes, 10 to the minus 2 hertz. That's 100 seconds. I'm plotting this down to about 3 millihertz. And then I'm going down to 1 hertz on the upper side. And what we can see is that in Singapore, we picked up energy below 1 hertz. And as we scroll down, in Palau, this was a little tricky, but it can be done. Below 1 hertz is where the peak of the energy is. So you have to now start tuning for this type of much lower frequencies. And this is a multi-resolution approach if you use linear analysis. And all of you that have the new PMCC version will be able to do this in log scales. You have to start stretching down to the very low frequency ends. The problem is that the IMS arrays were not really designed to go much lower than about 50-second periods, because that's their design specification. As it turns out, we do have energy down to a few millihertz. This is really long period energy, so it really packs a punch. These big eruptions go below the IMS specification for array configurations, and if you want to unambiguously detect these things, you just need a bigger aperture or a network. So this is part of the challenge that we have here. In a sense, some of these natural events, including tsunamis, they're beyond the IMS array specifications. And this is okay, because the sensors are still responding there, and we can compensate for that. So the Asia project is an international project. We aim to improve coverage and reduce the detection latency. You want information now. These big eruptions are easy. You can pick it up with a rock and a string if you could transduce it. Seriously, they're huge. And so smartphones can do this. We have specifications that we tighten so we can start quantifying performance characteristics. And so this is the V4R4 specification. And we plan to supplement IMS coverage with smartphones. And particularly Android is going to really help us out in those regions of interest. And we intend to integrate the Palau National Data Center with cloud servers to reduce infrastructure bandwidth and maintenance costs and vulnerabilities, in particular for a lot of these island nations who have challenges involving power and communications. This could be a tractable, sustainable solution. Thank you very much.
Thank you. I think we have time for maybe one question, and I would suggest that you keep the others for the discussion, which will be at 4:30. And I see one gentleman here.
Hi. Just a question for understanding. Is your idea to take those mobile devices as microphones and then average over all of them? Is that what
So your question is whether we can use the microphones in the smartphones and average. You can use individual ones, or you can use the collection of them as a network. As you saw in just this presentation, we built a network in 2 minutes, so we could do it. And David, you had a question. Is it quick?
It's very similar.
Okay.
These volcanic eruptions tend to be emergent, long-duration signals.
Yes.
If you've got a network of smartphones, I don't see how you're going to identify that as a volcano. It's just a loud sound happening sunlight. How do you propose to do it?
We will use time of flight.
Yeah, but it's an emergent. Well,
Yeah, it has an envelope, and it's going to hit a peak sometime. And if you can correlate on the envelope rather than the onset, and some of them are not emergent, some of them are impulsive. So again, you play the numbers games and then find out, can you see it move out? But yes, yeah, thank you.
Okay, thanks very much. The next presentation is on development of seismic hazard maps for Georgia by Mr. Tsereteli, please. Miss Tsereteli, sorry.
Over the historical period of time, the observed seismicity in Georgia is characterized as a moderate. Probabilistic seismic hazard assessments that based on standard methodology still remains effective to predict earthquake probability, particularly in a large time scale. In this work, PSHA is performed for Georgia by improved version of the standard methodologies that were developed in the frame of EMA project. And the basic aspect of this new approaches is to use hybrid empirical ground motion prediction equation developed for PGA and SA. In EMA project, strong motion data were gathered for crystal events for this region. The EMA strong motion database contains more than 5,000 strong motion records with a magnitude ranges between 3 to 7.6 and for source to site distance up to 400 kilometers. Here are presented strong motion data for Georgia in terms of magnitude versus the epicentral distances with respect to different soil conditions. And this is PGA distribution versus epicentral distances with respect to various soil conditions. And as we see, the strong motion data for Georgia is not sufficient. And for seismically active region where without sufficient strong motion data to build empirical model, very important is to very hybrid model. So we decided to derive hybrid empirical ground motion prediction equation using host to target methodology. Here presented the main task of our work. The first step is identification of active fault zone in each country, definition of simulation subdomains, and investigation of seismic parameters like stress drop, fault dimensions, and anelastic attenuation, and so on within the simulation subdomains. Verification of regional seismic parameters through simulation of parsed large earthquake. For the selected range of magnitudes and distances, performing scenario earthquake simulation for both target and host region. Computing the host to target scale factor and scaling of GMPs established for the region, for the host region to form GMPs for the target region using scale factors. And finally, verification of GMPs formed for the target region by validating with existing data. So two subdomains were chosen for Georgia. The first one is Racha region with active faults, and the host region for this subdomain was Tabas region in Iran with reverse fault plane solution. The second subdomain was the Javakheti region with active strike-slip faults, and host region for this subdomain was Turkey North Anatolian Fault zone. And in this study, we employed finite fault stochastic simulation. And in this step, very important is accuracy of input simulation parameters that were exist for host region, for Iran, and for Turkey. But for Georgia, we decided to verify existing input parameters through simulation of selected major events for both regions, as such parameters were not established before. Here are simulation results for acceleration time history and Fourier spectra for Racha earthquake. And this is the simulation results for Javakheti earthquake for acceleration time histories, and this is a simulation result for Fourier spectra for the same earthquake. We did such simulation for several earthquakes that were recorded on 2 and more stations, and obtained the seismological parameters for target region for scenario simulation, and here are presented these parameters. This table presented seismological parameters for host regions for scenario simulation. And finally, we performed ground motion simulation for each set of scenario events in both host to target region. The scenario set of simulation are performed for magnitude ranges from 4 to 7.5 with magnitude distances 0.25. The difference range of dummy stations is taken to be 100 kilometers, and these simulations are performed for rock conditions in both host and target region, avoiding the side effects. So here are the results of simulation for host region. This is Turkey, and this is Iran. Finally, adjustment factors was used in the scaling of ground motion prediction equations that allow us to calculate host to target ratio coefficients called CR for S for P ground acceleration, so for spectral acceleration. So here are presented these ratio coefficients for spectral accelerations for Turkey, Georgia, and this is for Iran, Georgia. Finally, we compared our obtained hybrid empirical models with empirical data for peak ground acceleration and for spectral accelerations, and we see we have quite good results. This is a comparison of existing data with those GMP models that were used before in seismic hazard calculation in Georgia in the various national international projects before EME project. As we see, our results are much more better. Here are the main steps in seismic hazard calculation, and these steps provide us with results that are input in seismic hazard assessment, and these inputs influence very much on the results. So these are seismic catalogs of active faults, seismic parameters as active rates and B-value, selected GMP models, divided GMP models, and so on. So one strong recommendation from GEM is we can, in seismic hazard calculation, we can use only those results that have been published in peer-review journals, and for that, our metadata are open. So EME project have already published his results in various international peer-review journals that allow us to use these results in seismic hazard calculation. To understand how we use this hybrid empirical ground motion prediction in probabilistic seismic hazard assessment, let us summarize what we have. So we have RGB distance value for each simulation point. We have host to target ratio coefficients for each simulation point as for PGA value for spectral acceleration, and the corresponding R is the distance value from the first table. And after this, we can easily calculate ground motion amplitude for target region. It is calculated using ground motion amplitude from host regions multiple to the scaling ratio coefficients. So if PGA and the spectral acceleration are estimated for a certain MW and a certain distances, we pick the corresponding coefficients from the related file. And finally, ground motion from target region are estimated according to this equation, where this one is ground motion estimates for host region from IGMP models, taking into account the wave function. Finally, ground motion for target region are estimated according to this formula. All this was implemented in OpenQuake software some months ago, and now we can possibility to calculate seismic hazard map for Georgia, new seismic hazard. We calculated probabilistic seismic hazard map for 5 and 10% of exceedance probability for 15 years for peak ground acceleration and so for spectral acceleration. This map above is the normative seismic hazard maps that are used now in Georgia, and this map is the basement of our building codes in Georgia. If we compared our obtained map with this, and this map are expressed in terms of peak ground acceleration and intensity at MSK scale. It was adopted in 2010. If we compared our obtained probabilistic seismic hazard map for 2% probability of exceedance in 50 years, differences is very significant. Here are presented these differences. So if these differences are even high if we compare our map for 10% of exceedance probability in 50 years that, as usual, show lower, a lower value of PGA value in seismic hazard. That means that normative seismic hazard map were not estimated correctly. The models that were used there was not correct, and this map should be changed. Thank you very much.
Okay, I think we have time for more than one question.
Regarding the correlations with numerical hydraulic predictable and data, how much the correlation coefficient the model and the
Correlation coefficient with
empirical data with the major data,
empirical data with
the hydraulic model data against the major data.
Empirical equations that are based on the empirical data. This was another step in earthquake. One direction that was to pick up GMP models from selecting criteria that are based on the empirical data. But in this MA data, the most, I show that there are about strong motion more than 5,000, but most data comes from Turkey and from Iran, and the data from Caucasus are really very few. So selected GMP models are more prone to this region, to Turkey and Iran, not to Georgia. That's why we are decided to develop the hybrid empirical ground motion that is a different direction. It was different direction in EMA project.
Nino, I have another question about the maximum magnitude.
Yeah.
How you calculate it, for example, the maximum magnitude for Caucasian?
You know, there are several methodologies. There was for those sources for which we have historical data itself, because historical earthquake is evidence. But actually, but for other zones, we are calculating it from Gutenberg-Richter relationship, and and the maximum magnitude was taken for 2,475 recurrence periods that are corresponding to this interval period. Yes.
Okay.
Thank you very much.
Okay, thank you.
So with the next presentation, we stay within the topic of quantification of earthquake hazard, this time in the Hindu Kush Pamir Himalaya region, and it's by Mr. Daya Shankar. Please.
Yes. Yeah. Main aim of scientist and engineer is to reduce the effect of earthquakes and try to save the life of the people and their property. So in this direction, we have quantified the future earthquake hazard in Hindu Kush region using the IMS data. Since for the analysis, for any earthquake analysis, a good amount of data and reliable data is necessary. So for the case of earthquake, it is very difficult to collect the data and maintain the data. For any other subject, you can get the data within 1 hour, 1 day, or 1 month. Suppose in the physics, you can install the instrument and you can get the data in maybe 1 day, 2 days, or 1 month. In the most typical cases, like in biological data, you can culture something, maybe it will take 6 months, 1 year. But in the case of earthquakes, we have to wait for the earthquakes. We cannot invite the earthquake to come. So it can take the time, maybe 1 day, maybe 1 month, 10 years, 100 years, maybe many decades and centuries. So to maintain and we have to maintain our instrument going on around the clock. So in this direction, CTBTO is doing by installing the IMS network, global networks. So I have used that data for the quantification of earthquakes in the Hindu Kush Pamir Himalaya. So nowadays, earthquake hazard is perceived differently than 1 or 2 decades ago due to the occurrence of unexpected large earthquake in a particular region. Although there is no any particular method for the estimation of the earthquake risk, but statistical models are very popular among the scientists. So among these, extreme value method given by the Gombals in 1941 is important, very important for the analysis, and he was the first man to use this method for the flood analysis in 1941. After that, Narcudis in 1945 used this theory for the occurrence of earthquake in Southern California. Scientist Lomnitz, 1974, uses this method for the estimate of design earthquake parameter and their recurrence times. After that, this method became very popular among the scientists, and all over the globe, people try to use this method for the estimation of earthquake hazard in Soviet Union, New Zealand, America, Europe, India. So many people have worked on this, and they have used this method. So for this, I have used the IMS data and Gumbel stream value theory to determine the probability of occurrence of stream and their return period and their risk in the Hindu Kush Pamir Himalaya. So for this model had different characteristics. So this model is applied because it is able to emulate the known historical earthquake data and it can produce suitable formulation for which the probability of the future event of interest can be inferred within a specified certainty for a particular region. So this model have three different characteristics. First, this if earthquake magnitude limited, and if the number of earthquakes per year decrease with time size, and if the individual events are unrelated, that is, they are the main shocks. So you can use this model for the estimation of the earthquake hazard. Then the probability of non-exceedent of earthquakes of magnitude m in 1 year time period can be calculated by this formula, Pm is equal to exponential minus alpha, exponential minus beta m, where alpha and beta are the parameter. You have to calculate this. In 1974, Lomnis shows that if you have the homogeneous earthquake process, then the cumulative magnitude distribution can be assumed like Fm is equal to 1 minus e raised to power beta m, where beta is the inverse of average magnitude of earthquakes in a particular region under consideration, and alpha is the average number of earthquakes in 1 year above magnitude 0. Then the annual maximum magnitude will be distributed as like equation 1 I have shown. So model annual maximum magnitude you can calculate by this. Ln is equal to minus Ln P is equal to Ln alpha minus beta m. Above equation can be evaluated by taking double logarithm of the equation first one, which I have shown. Then the model maximum magnitude U can be calculated in terms of alpha and beta. Is given by U is equal to Ln alpha by beta. The model earthquake magnitude in 1 year period can be written as this. The expected number of earthquakes in a given year which have magnitude exceeding m can be found by the relation Ln is equal to Ln Nm equal to alpha Ln alpha minus beta m, and the return period can be expressed by the equation number 6, Tm is equal to 1 upon Nm. So in this way we can calculate the earthquake risk of magnitude m in a particular period t, that is the Rtm is equal to 1 minus alpha t exponential alpha t exponential minus beta m. So we have divided the whole data. We have used the 17-year IMS data from 1999 to 2015. So we have divided the whole data into different intervals, that is the extreme magnitude m1, m2, like that. So we have calculated the probability Pi is equal to I is equal to n plus 1, where I varies from n to n, where n is the total number of earthquake data. So according to Nopaf and Kagan, 1979, this equation 8 gives the bias result for the large earthquakes. So he has suggested some correction in that. So he has given this P is equal to I 0.5 n. So we have also calculated the A and B value for the particular region. This is the Hindu Kush, Pamir, Himalaya. So A and B value are the very important parameter to describe the seismicity of the particular region. So for this case, the A value is 1.45, B value, and A value is 8.5209, and A value is very sensitive for the missing data. If you have missed the data for a particular region, a particular year or region, then it will give the wrong result. But B value is almost constant for a particular period and particular area. So this model has been applied in the Hindu Kush, Pamir, Himalaya. This is my region. So here earthquakes occurrence are due to the continent collision between Indian and Eurasian plate. But it cannot, because this region is very seismically active, from large to great earthquakes has occurred in this region. So this cannot be only explained by the continent collision, but it can be explained that the thermal convection below the Indian plate and the flow of the upper mantle in the Tibetan plateau is the main cause for the stress and occurrence of the great earthquake in these regions. So this is the seismicity map prepared for this region. This indicates that the region is seismically very active. So about the seismicity data, I have already told you that 17-year seismicity data I have used, and this is the IMS network, everybody know this. So we have analyzed the result, and for this, calculation of Gamble annual maximum distribution of estimate of alpha and beta has been tabulated in table 1. So from table 1, it is clear that from 1999 to 2005, every year we are getting the extreme magnitude. And table 2 describes the parameter of alpha and beta, which has been calculated by plotting this extreme magnitude with the reduced rate in figure shown below. So if you see the correlation coefficient, it is 0.94. So it means the data is goodness of the data is very accurate. So for the earthquake hazard, Lomnitz, people use the Lomnitz equation for the estimation of the earthquake hazard. So you can define the hazard in terms of earthquakes, occurrence of the earthquakes, or damage scenario for a particular region. So there are people, they can define on their own way for the particular earthquake hazard. So you can find the earthquake hazard by the equation this STM is equal to 1 minus exponential alpha t e raised to power beta by. So using this equation, we have calculated the variation of extreme magnitude with their probability by the table figure. These three. So there is a cases when there is a non-zero probability, that is no event occur during given period of time. So and probability of any particular event occurring never reaches to probability 1. That is the particular case. So probability is always less than 1. So for the example, if m is equal to 5.5, if you get probability 1, that is almost 1, 0.999. So it means for a certain period of time, 5.5 magnitude is certain to occur in a particular region. This means, so we have also determined the predicted annual number of earthquakes for their return periods. So these are tabulated here. And most probable large earthquakes hazard HM for a particular magnitude in different periods, 10 years, 20 years, 30 years, we have tabulated, can be estimated. And we have also estimated the design earthquake magnitude. Earthquake engineer use design earthquake magnitude and define many ways. And they also use the recurrence period instead of average return period. So this can be estimated by these equations. And design earthquake recurrence period with 89% probability we have calculated for this region. So it has been tabulated here, quantified here. So main conclusion are the IMS network data is used because it represents continuous and complete set of annual maximum magnitude events. The results are potentially useful and can be used to determine the variety of statistical, including average recurrence period of annual maximum magnitude earthquakes, probabilistic seismic hazard assessment in a particular region. Results are informative for seismic threat and related earthquake engineering information. Usually require estimate of return period, probability of accident of a specific level of design load criteria, or external safety condition. The most probable annual earthquake magnitude for my case is 5.5, and for the 50-year maxima is 6.6. It means every 50 years we get the magnitude 6.6 earthquakes in this region. The predicted value are also useful for engineering application and decision making for planning human settlement or societal infrastructure development in the region. The estimate can be considered to be two-way reliable because one way the value of alpha and beta do not change much if you use the large or short amount of data, and other the complete and reliable IMS data. Thank you.
Thank you. We're running a little bit behind, so if I may ask you to write down your questions and ask them during the discussion so we can go through the rest of the agenda. Thank you. So with the next presentation, we move to another area of application of IMS data, which is monitoring the behavior of blue whale populations and understanding their migration patterns. Ms. Tracy Rogers, please.
Thank you. So a bit of a change from earthquakes, and I don't know how many ecologists are here, but this data is incredibly useful for us as well. And a lot of the reasons that the last speaker spoke about the continuous data, complete data sets, makes it great for us ecologists. Long-term data sets were deemed as being boring and so not funded for a long time. So with the advent of climate change and different things happening in ecosystems, it's what we actually need is this long-term data sets. So the CTBTO data set has been, we've been using the hydroacoustic data set, has been fantastic. So I'd like to introduce you to my co-authors, Gary Trong, my PhD student, Joy Tripovich, a postdoc who's just moved on to a lovely, fabulous job, which is wonderful, and Neza at the end, Neza Balcazar, who's a PhD student who's just finished. So why blue whales? Well, we started with working with the blue whales. We work on lots of different animals and different ecosystems, but blue whales are sexy, so you can get grants for it, really. You know, it sounds a bit trashy, but it's true. The largest animal ever. And to give you kind of a scale on how big they are, one blue whale, about 40 elephants, so they're really, really large. They're long-lived, about 100 years that they can live to. And last century they were taken out because they were so big. They were actually really targeted as a species for harvest. So they were taken to almost extinction, and even today we know very little about them. A lot of the other big baleen whales have actually returned or are returning. These guys haven't. And in fact, many of the populations, those in the southern hemisphere, the Antarctic blue whales particularly, are still critically endangered. So our study site, Southern Hemisphere, and the Southern Hemisphere blue whales are those that haven't returned, the return rate has been the least. And it's a really difficult environment to actually work in. And it's really complicated because we have all these different kinds of groups of different blue whales. You have the Antarctic blue whales, down feeding around in the Antarctic, moving up further north to breed somewhere in equatorial zones. We don't even know where those breeding zones are. And their migration pathways, we're not really sure for many of those populations where they are as well. There are also these smaller blue whales called the Pygmy blue whales, but they're not much smaller and they look pretty much the same. So there's huge amounts of money gone into surveying the return of these blue whales, and there's still big black holes around where they are and how the animals are returning, largely because they're solitary. You see one animal, you're not going to see another one for a long time, and they're at low densities. There's very few of them. They're sort of secretive. They're way out at sea, unlike sort of something like a humpback whale that you would have seen that sort of jumps around all over the place, show ponies. But an advantage of these guys is that, like the earthquakes, they produce dead, boring, structured standard calls that they produce in a very rhythmic fashion. In the old days, they thought actually they weren't an animal, that they were actually some form of human-made sound, which for us is fantastic. Build a detector, run it through massive data sets, and boom, there you are. So they're fabulous for us. So in each one of these different whale populations across the southern hemisphere has an acoustically distinct different call. And some of these populations that they've started to look at even they're genetically distinct. So this has been incredibly handy to actually tease apart what's happening with these different populations. So the big ones, the Antarctic blue whales, will take them out. In the Indian Ocean, if you whack the Antarctic blue whale in there, you have 4 different acoustically separate groups within the one ocean. So it can become very complex in teasing apart, if you were doing it visually, what's happening with these populations. But doing it acoustically, it's working. It has enormous benefits. So what I'm going to do is show you a little bit of work that we've done so far and work that we're playing with at the moment. So I'm going to target in around Australia, just because we've got more on there at the moment. And we've utilised not only the CTBTO data, but also NOAA data sets from looking at the VENTS program up around the Lau Basin, up above Australia. And IMOS is an Australian program, Integrated Marine Observing System, where we have a series of arrays also around the Australian coastline. And working with different collaborators from Scripps, Oregon Uni and Cornell Uni. Okay, so the first project, what we did is we were looking in the Indian Ocean along the Western Australian coastline around in the Bight of Australia, and primarily this area was known as being a Pygmy blue whale, one of these small blue whale feeding sites, and this was one area where the blue whales are actually returning really well, and people go to that area to study them. That was really well known. But when we started looking at acoustically, and another group as well, we found actually the Antarctic blue whales there as well. And we were saying before, they actually look the same, and the Antarctic blue whale is one that's critically endangered. So finding that actually there's all these Antarctic blue whales there as well, it's like, oh, okay, that's great. Then on the other side of Australia, in the southwest Pacific, that a few years ago, the Australian Antarctic Division found a different group of blue whales down below New Zealand, a different kind of call. And so we're wondering, okay, this New Zealand-speaking blue whale, how far do they extend, and how many are there, basically? And so what we did was looking at the arrays around the up and down. The Lau Basin is extending. That top red dot is about Samoa, down to just above New Zealand. So it's about 1,000 kilometres, and there's about 17 different buoys along there. And what we found is these New Zealand-speaking blue whales are all the way up the coast past Australia, just off the coast of Sydney, and moving up in the summertime, up past Samoa, which was amazing because Sydney and Melbourne are huge industrial, massive cities that sit on the coast. We have all these surveys and things happening. We had no idea blue whales were migrating past the coast, so we were incredibly surprised that this New Zealand-speaking population is right off the coast of Australia, because there's this kind of rivalry between New Zealand and Australia, so it was kind of good. And we always claim everything of theirs that's good, so now they go, well, we actually own all your blue whales. Now, the other thing that came as quite a surprise was that the Antarctic blue whales were also migrating past the coast of Sydney all the way up to Samoa. So here we found, in a space of a few years, all these populations that we had no idea were actually there. So work we're playing with at the moment is looking at the one site, the CTBTO site off Cape Lewin. This is looking at the Australia-type blue whale. And this is a seasonal pattern of when we see them, where we detect them off the coast. And looking back through, this data set runs from 2002, and we're just looking at the data from 2016 at the moment, that we expected to use this data set as this population is anticipated to be recovering. So they should see some sort of using the acoustics as an indication to go, okay, this is the rate at which they are recovering. But this is what we found. This is the number of detections per year. It was like, what's happening here? So what we did is we looked at environmental data alongside these detections. Now remember, there's this seasonal pattern in the detections as well. So if you take that actual, looking at number of detections per month, and you see that this between 2008 and 2012, we had this massive spike in the number of detections of animals. Now that site is an area where the animals are moving past. So we're not recording the same animals over and over again. It's genuinely more animals were detected in that time. So looking at satellite telemetry data, sea surface temperature, sea surface height, chlorophyll at the hydrofoil. Chlorophyll A is a proxy of productivity, although crude. And then chlorophyll A at body upwelling, which is a really close by known feeding site of these animals. And then the Southern Oscillation Index, which for Australians and people from South America, our kids even know about the ENSO cycle. For anyone else, it's probably not relevant. For us, it means whether we're going to have a drought or a fire, or we have to worry about losing the house. So even my 11-year-old knows about what's happening with the ENSO cycle. And what we did is we took a model selection approach. We looked at time series analysis. Because we've got the animals changing numbers per year and also this cyclicity and the seasonality, we needed to look at season and change in time in our analysis. So what we found was that there was a relationship between the number of whales that we were doing, whale calls we were detecting, sea surface height, positively, not with sea surface temperature, chlorophyll A at the hydrophone, not so much. Chlorophyll A at the feeding side, yes, there was a positive relationship. Where there was a really strong relationship was with the Southern Oscillation Index. So basically, through that time, this is what was happening with the ENSO Southern Oscillation Index. And La Nina up the top, El Nino down the bottom. And I'll come back to those in a sec. But if we put the whale detections over the top, whoops, no. If we put the detections over the top, the time when we had the highest detections is when we had a sustained La Nina event. And the system tipped into La Nina a couple of times, only just, but it was when we had those sustained events that we saw this larger number of animals in the area. So, okay, what is ENSO cycle? What happens? In a normal time, during the normal phase, we have cold water off of South America, and the trade winds bring a little bit of warm water across to Australia. During La Nina, this is when all the whales were off our coast, you have these really strong events. So South America's really happy, Australia's really unhappy. We get fires, we get drought, and they're having lots and lots of pilchards. But there's this warm water intrusion that comes through and down the Lewin Current, which warm water is usually associated with poor conditions. So that's a time we're seeing lots of whales off that coast. So something else. So we're just looking at this. In fact, this was like last week. So strengthening of that Lewin Current may have actually increasing productivity or some other bigger action happening within the ocean so that animals are coming and feeding off the coast of the Bonnie upwelling. So the CTBTO data has provided us with these long-term data sets to be able to look at different things, finding new populations that we didn't know were there, and also that the ENSO cycle is influencing migration patterns of the animals off the coast. But the big take-home message for us is that across the southern hemisphere, the oceans, we've got this warming events happening with time. But then on top of that, we've got all these cycles happening. So teasing apart what's actually happening, how the ecosystem is actually changing, we need these calibrated, continuous, long-term data sets, of which this is absolutely fabulous. So thank you. Thank you for listening.
Okay, if you have maybe one question, please, and we can keep the rest for later, please.
Thank you. That's a really technical question, I believe. What is sort of the frequency range of blue whale calls, and how do you define what one call is?
Yeah, so their calls, it depends on the different population group, but they range between about 20 and 30 hertz, and they're highly stereotyped. So the Antarctic blue whale is the classic. It's this sort of a Z-shaped call and highly, highly stereotyped.
Okay, thank you. The next presentation is being given by Ms. Lucrezia Terzi, and it's about worldwide seasonal variation of beryllium-7 as estimated from IMS data.
Good afternoon. I'm Lucrezia Terzi. First of all, I would like to thank Martin Kalinowski, without whom it would not have been possible to write this work. And also Michael Schembner, who was really a great help in developing some of the interpolation plots that you will see later on. So the aim of this work we present today is basically to highlight the importance of the RN, the radionuclide data set, which is a unique global data set provided by the CTBT. The network we used is 63 operational stations. There may be more now, but at the time we looked at the RN network of mid-2016. And we took monthly averages of beryllium-7 concentration from those 63 stations for a total of over 200,000 samples of data. Now, why did we choose beryllium-7? Beryllium-7 is a radionuclide that it's an ideal atmospheric tracer because it attaches to aerosol particles and is then transported with atmospheric circulation. And that's what you see in the plot there. You have time series from 2 stations that are in mid-latitudes, where these seasonal trends are highlighted. Those seasonal trends, so the maxima and the minima, indicate the position of the conversion zones of Hadley-Farrell cell for the maxima and the intertropical conversion zones where you see the minima. Whereas the Hadley-Farrell conversion zone, so as I said, it's marked in Hadley-Farrell cell, it's marked in blue, and by putting 2 stations together, one is in Australia and the other one is in the Philippines, then you can see the transition of the cells. Yeah, and they have a 6 months, quite a regular shift over the years. You have 14 years of data in that plot, yeah, from 2001 to 2015. So the first step was that we divided our 63 stations into groups of 12 longitudinal bands. That means that we took bands from the northern to the southern hemisphere, having a very similar longitude. And then we looked at time series interpolated into surface graphs. This you see in the right plot over there, which confirms the theoretical model that you have intertropical conversion zones where we have very low concentration of beryllium. That's the middle one in green and white, alternate by high concentrations, which indicates the Hadley-Farrell cell conversion zone. Okay. We did the interpolation for all 12 bands, and as you can see, you clearly visualize the cells. So from the polar, Farrell, Hadley, the intertropical conversion zone for northern and southern hemisphere in all 12 bands. Now, what you see up in the corner, that's band number 7. It's the Middle East area that has a very strong concentration of beryllium-7. And there was a paper that was just published now, relates to tropopause faults. So there's an injection from the stratosphere of air that produces this very high concentration. And that's typical of Middle East in July and in August. We did exactly the same work for the equatorial band. So in this case, we transposed the station. We used all stations along the equator. And the reason we wanted to do this is instead of looking at atmospheric cells, we wanted to study meteorological processes such as El Niño, southern oscillation, the Walker circulation, and the monsoons. So, sorry, where is the point? The red one. Okay. So what you see over there, yeah, you have a much higher concentration of beryllium, and that relates to El Niño years, because during El Niño years, exactly on the South American coast, you have a downward air flux. So the increment of concentration are highlighted during the ENSO period, and there is a correspondence between high beryllium concentration and downward atmospheric influx. The third step was to create a global concentration map. So we produce global concentration maps of monthly beryllium-7 activity concentration by using the 63 location and interpolating them using a multi-level B-spline methodology. And here we have an animated version of this. Is it working? Okay, so what you see in light blue corresponds to the ITCZ and the polar Farrell conversion zone. In dark blue are the higher concentration of beryllium that indicates the area for the Hadley-Farrell cell. So the BE levels, the beryllium-7 levels increase in June and in July in the Middle East towards East Asia, and then decreases until a minimum is reached in December. In the southern hemisphere, the Hadley-Farrell cell conversion zone is strong in December and January, and then decreases until a minimum is reached in May and in June. To highlight the small modulation, so the changes that are happening every month, we normalize the data. By month, we calculate the monthly average divided by all the 12 months. And by doing so, you can see that there is a visible northward trend in the first 6 months of the year, and then a southward trend in the last 6 months of the year. And here again, we have the animation of these plots. The peaks are reached in the first half during March and April, and for the second half in October for the southern hemisphere. So now we come to the highest point of this talk. With in the article, if you're interested, we go much more into details on correlation of beryllium-7 time series with several meteorological processes. But we highlight here the Indian monsoon because this has huge civil application. So what we looked at a study from Stolbova, where she studied Pakistan and India in regions that are highly affected by Indian monsoons, and looks at humidity and temperature. And basically, when the temperature drops into one location and raises in the other location, that becomes a cross point. And 3 days after that, it's the onset of the monsoon on a regular basis. So we thought, like, can we do the same with beryllium? So that's what we tried. And we wanted to answer the question whether it was possible to use beryllium as an early warning indicator for Indian monsoons. So what we did, we took 2 stations. This is Malaysia and this is Japan. And Japan is affected in that region by Indian monsoons around the month of August. And what we saw is that there is a cross point between the concentration of of these two stations. And when there's a drop in the beryllium-7 concentration in Japan, and it crosses it basically reaches the same level as the one in Malaysia, 30 days after that, approximately, there is the Indian monsoon onset. So it's shown to be quite regular, because in the plots you see from 2012 to 2015. And I really hope that meteorologists will pick up from here and further test this methodology, which could also be used as a complementary method with satellite imagery or other. So to conclude, the IMS provides a unique opportunity to study several meteorological processes at a global scale. And I think the fact that it's global, it's the highest point, yeah? Because there's been several studies already produced on beryllium-7 time series for meteorological processes, but always on a local or regional scale, yeah? But here you can see, you can use them for the whole world. So in the publication I told you about, we also compared beryllium-7 concentration with other processes like tropopause heights, sudden stratospheric warmings, solar energy particle events, the quasi-biennial oscillation, and Indian monsoon, and others again. So there's really a huge variety of atmospheric processes that we can study. And finally, I really hope that this work will raise the attention of the scientific community and that experts will further test this approach. Thank you.
Thank you, Lucrezia. So we have time for questions.
Yeah, you made it very well, 10 minutes.
Thank you for the nice work, which is really very effective for all others, because I'm working in the station, Kuwait station, and my question will go back to the same point we say the Middle East have the June, July, August, the highest concentration of the beryllium-7, which is the cosmetic radionuclides, as you know. And you mentioned in your presentation that this might be the injection from the stratosphere to the troposphere. I need to clarify to you that within these 3-4 months, like July, August, June, July, August, Kuwait and the Sahara area is very dusty, especially in the summer times. That might show the resuspensions of the dust which is accumulated in the surface to the monitoring RASA systems or the IMS or the station which is existed in that area. It's just a more.
Okay, thank you.
At the back, please.
Yes, question related about the early warning monsoon. What is the mechanism causing that so-called early warning? So beryllium-7 drops.
The mechanism. It's the cross correlation of these two stations, of concentration at these two stations. When they cross each other so that they reach a approximate equal level, we saw that 30 days after that there's an onset.
Okay, then a continuation, relatively recent, also sodium-22 maps were produced from IMS data.
Sorry, I didn't hear.
The sodium-22 maps using IMS data were produced. Do you have plans to do similar studies using sodium-22 extracted from the IMS data?
Yeah.
I have still one question, probably a non-expert question. It's if a nuclear event occurs, how the map which you developed will change, and it's by the percentage of the, and how it could be recognized really that that event occurred.
The beryllium-7 is a cosmogenic nuclide, so, and it's actually monitored by the CTBT for energy calibration purposes.
Only. It's
So
not depend
I
on
don't think we should be
the
affected.
tracing and the searching, no?
No, I don't think so.
Okay.
Thank you.
Thank you. Okay, the final presentation of today is by Justin Herzog on using social media to aid in the refinement and understanding of seismic and acoustic ground truth information, and it's eligible for the Young Scientist Award.
Well, thanks for coming. Again, my name is Justin Herzog. I'm a geophysicist with ENSCO. So the title of this slide, like she discussed, is using social media to aid in the refinement and understanding of seismic and acoustic ground truth information. And I'd like to thank the co-authors, Sue Nava, Chip Brogan, and Nancy Marin, and Jeff Hetrick for all of their help and assistance with this project. So over this talk, we're going to be going over some motivation for this project, our initial findings, integrating the social media with the seismic and infrasound data sets, go over some example data sets and success stories, the conclusions, and some future work. So the motivation behind this is we wanted to investigate the validity of social media applications as an information for anthropogenic seismic occurrences. We wanted to get a better handle on the location of these occurrences and also the approximate time of the event. Because like most news sources you read, it'll say, well, the event happened early morning, or it happened in the afternoon. Well, what does that mean? You have like an 8 or 12 hour window over which you can query for the data. And so we want to get a better handle on this. And then here's just a little cartoon if you can read it. This is in relation to earthquakes. So an earthquake occurs, someone feels the shaking, and they report it on social media. This is in reference to tweeting, so when they tweet about it, at some point it overtakes and travels faster than the earthquake itself. Other people receive that before the earthquake hits, so they're notified. And the last picture is, unfortunately, their first reaction isn't to find shelter, it's to retweet about it. And that may be true. So surprisingly, some of our initial findings were that we found only about 1 or 2% of social media users allow their application to use their location. So this made it pretty difficult for us to obtain that origin location. However, they do provide important information regarding to the origin time. They do talk about where they're at, and they give us clues about what the event is. But we need to be careful. We don't know how reliable that really is. When someone says that it's an explosion, well, it could be an earthquake too, or vice versa. And we found that many users repost to emphasize an event, and it can dramatically increase in a short amount of time. So here's an example of an extraction from some social media. We call this the anatomy of a social media posting. So I couldn't believe, as a scientist, I couldn't believe how much information was actually in a social media posting. And we actually stripped out a lot just so we could increase the font to make it legible. But really, for our sake, what's most important is that origin information and possible source type. So here we can see that there's a posting on, it gives us a date, a time, the location, which is in Manchester. It says that there's an event, a bombing. We have some more location information. So this is of the user, where they originally downloaded their app, but not necessarily reflective of where they are at that instance. We can see the place is null, meaning that they turned the location off. And we also look for some other things. If some of these come up as true, we disregard them. And here's, visually, we can see how these social media posts are represented. So when someone starts posting about them, we can see that they're all concentrated in one area. And I believe this is about over an hour worth of time. So people start talking about explosions, talking about the event. And soon thereafter, there's people that follow them and retweet it or repost it. And it spreads pretty quickly throughout the world. So the evaluation of messages, how we extract the data. So we went through multiple parameters of this data set in various languages, looking for explosions or bombs, bolides, meteors. We tested that the location was with about a degree of the post, and we limited it to 4 hours, which we learned that was an immense amount of time. It's really within like 30 minutes. But really what we're doing is we're trying to cluster all of these events together and extract that information, the information that's relevant to us to populate our seismic queries. And our processing flow, so we look at the social media data, mining with qualifiers. So again, the clusters of that information that we get back. We extract the origin information, the latitude, longitude, as well as time and even possible source. And again, we're not sure if that's how reliable that is though. Which at point we query for the waveforms using this metadata. And in some instances, we have further visual confirmation from these news media sources. So for first example, we looked at a terrorist bomb or explosion in Kabul, Afghanistan. So this happened on May 31st of this year. So you can see the first posting that came in was at about 3:54 GMT. And when you go to the news, it says early morning. Well, again, what does early morning mean? I don't know. To me, it would be maybe 6 a.m. But so we're able to get this time. So this helps us. So someone posted an event. We know that it happened prior to this event. Prior to this time, excuse me. And we were able to go out and populate to obtain the seismic data using this. And so you can see here we located our event using the seismic data and came up with an origin time of about 3:52. So someone posted on social media within 2 minutes. But when you think about it, if you feel something and you're on your phone, 2 minutes is a long time. So graphically, we can view this and see that here's our origin time of what we determined seismically from our seismic traces. So the first posting came within about 2 minutes, and then we get more original posts here, and then at about 8 minutes, it starts to be reposted and liked and favorited. And so at this point, really the information here is no longer relevant to what we're interested in. And so for this event, we were able to also obtain a visual confirmation. So this is typically hours after or at some point further later that we were able to see images from the media. So we have a before and after of our event. So we can see that it did happen, or it looks to have happened on the surface. And we also see that it generated a large crater. So no longer our probability of an explosion has just increased, as opposed to calling this an earthquake. But prior to seeing this, it would have been difficult to even say. And you can also see our seismic location with relation to the blast. So using this image, we were able to see how close our location was to the blast. And we came within about 830 meters. Our second example is a gas explosion in Marengo, Illinois. And this was a really interesting example because we got tipped that there was an explosion in Illinois. And I was reading through some news articles, and the news said, yeah, it happened around 9:50 GMT. And I said, well, there's no way that it took someone almost 40 minutes to post about this. No one's that slow, even though I think it was like 3 a.m. in the morning in Illinois. So I told my colleague, if you don't mind, go back, query for earthquakes, query for shaking within the last hour, and see what you get back in this location. And in fact, people got back, or we got back, earthquake. So people's first response to this was, an earthquake just happened. And this is, earthquakes happen every so often here. It's not California. But earthquakes happen. And that was their first instinct, is that it was an earthquake. And then maybe this person saw it in the news came on, and they got tipped off and saw that it was an explosion. So you can see that there's some complexities here with our data sets. And obviously this would change from location to location. So where I come from, Florida, in the United States, I wouldn't say, oh, I just felt an earthquake. That wouldn't make sense. I'd say, wow, I think that was a sonic boom from the shuttle, or you know, a bolt of lightning, or the train just went by. But I probably won't be tweeting about trains. And here we can, again, use further visual confirmation. So what we have here is we were able to obtain the imagery from a news source. So this was the after. So instead of starting with the before, where we didn't know where the source, the origin was, we have the after. But knowing this information, we can go to Google Earth and find that the origin was, in fact, right here. And this was also a great example. One of the users, the 1 or 2%, left their location on, and their location is within about 1.5 kilometers of the event. So in conclusion, I think using social media as a metadata, it really can provide important information about a seismic or acoustic event. We can use this in location refinement. We can use this to improve our velocity models, or figure out why our location's off. We have the ability to tailor queries to seismic acoustic events of interest, whether it's explosions, bombs, meteors, or bolides. And it was successful that we saw in obtaining origin times for the Kabul, Afghanistan event, and also for the Marengo, Illinois event. So for the Illinois, we have to also take advantage. An example like that, where we need to retroactively query for certain terms, like earthquake or shaking in certain regions that are prone to those types of events. And this process can be applied to various social media outlets. And some future work, where to go next, is really to integrate the geocoding and entity extraction. So since there's only 1 or 2% of people that use their location, they're always saying where they're at. So people are saying Kabul, Afghanistan, they're saying Marengo, Illinois. Even though their location's off, we can use this information to populate that location. We can also use the social media posts to prompt automatic retrieval of waveforms by federated request to IRIS. We'd also like to incorporate a user interface for visual representation of the social media data for each event, just to make it easier for the analysts. And also use the suspected origin time from social media to populate seismic acoustic data with the appropriate arrivals. So thanks for your time.
Okay, are there questions for this presentation? Please.
Possibly how you will integrate a different language, which is from different country, in the system.
So for some of the social
Like
media,
Arab, French, different language of the social
yeah,
media.
you just
Difficult.
Google Translate explosion and use that across multiple languages for, you know, whether it be Facebook or Twitter or whatever social media you're interested in, and it goes out. Because to my knowledge, Twitter's worldwide, so that's how we would integrate it. Yeah, so, and I'm sure there's some slang, and obviously I'm not privy to all this. Yeah, most of ours, as far as I know, were in English. I think we did scam, but most of ours were in English. But it is another complexity, though. No, you're correct. Yeah, thank you.
I think we are moving to the discussion, and we thank our speaker now. And we had 6 very interesting presentations, and now there is a time, 15 minutes, for discussion. It could be comments, could be questions to particular speakers, and I invite all to contribute to the session. Yes, please.
Check. May I ask what type of social media do kids use in your country? Is it Twitter? WhatsApp? Thank you.
Yes, please.
Actually, this sessions was very nice sessions, and I am happy to see most of the presenter, which is good works now. I have just two questions for the Indian. Was they doing the hazard risk assessment for the
Indus Valley, Himalaya.
and you use about all the MS data, all the MS data.
Yeah.
And look like for me that the models, as you put high retention times, the probability of prediction, it's become one from your tables. That's mean it is give you a trend of the time. But there is a possibility to predict the earthquake before, at least sometimes, like I hear some scientists now, they try to use the migration of seismicity or immigration of radon gas as an indications for the escape from the movement of the earth to the as uninitiated to the seismic event. Is some research happened in that area?
Actually, in response to your question, at present, due to the limit of our knowledge and due to the limitation of our infrastructure available to us, our scientists all over the globe, earthquake prediction is not possible. Reliable earthquake prediction is not possible at present. So people are estimating the future earthquake hazard in a particular region. So earthquake prediction is nothing but it is a step-by-step seismic hazard assessment. So we are approaching toward the earthquake prediction. So many people or many scientists all over the world, maybe they have allergy about the earthquake prediction word. So they have just deleted that, and in place of that, they are using the earthquake forecast. So at present, it is not possible to predict the reliable earthquake at a particular region, time, their occurrence time, their magnitude, and place. Three things needed for the earthquake prediction, but you can one or two you can make the possibility to predict, but it is not possible at present. Okay.
Any other question? Yes, please.
Thank you. I'm Paulina from Ghana. Yeah, this question also goes to you. Doing a probabilistic hazard assessment, I think you need quite some data.
Yeah.
I'm wondering if what you presented, you are using only IMS data or your local network data. Thank you.
I wouldn't like to, but I will.
We have tried to use the reliable earthquake data. So for the Gumbel's theory, for the determination of the Gumbel's parameter, there is no need of a huge amount of data, because the parameter doesn't depend on the length of the data. If you have short amount of data, so the value have no change, very little variation, but it is under control. So because the IMS data started maybe in 1999, maybe. So June 3, 1999 up to 15 January, something like that, I have used the data which are available at the IMS. So 17-year data I have used. I think it is considered to be reliable. So I have used. Otherwise, you can get historical data for that area from the USGS or ISC or different catalogs. You can make your catalog. Right? I think.
But so you have a local network in India, so why don't you integrate it? Because you need a huge data to do this sort of analysis. So I'm wondering why you are using only IMS data and not...
Actually, I am not involved in the monitoring system. I am not involved in this laboratory to monitor the earthquake or record the earthquakes. So there are other people in our country or our department, they are looking that. So I am just using, I am user to take that data to analyze something for the scientific community.
I think it's before moving to another question, I would like to comment here because it's a there is a discussion in the seismological community about this, how much reliable is a probabilistic seismic hazard assessment. It is reliable for a specific average value, which is going to the engineering purposes. Yes. However, it is a major point is the extreme events. That's why the theory which you suggested, it works quite well on the data which you have. But that is, I would agree with Paulina that it's a really very long time catalog to get this maximum magnitude and incorporate it in seismic hazard assessment. Because it's a 15 to 20 years catalog cannot give you extreme for such complicated region like a Himalaya, where the magnitude 8.5 and higher even might occur.
Yes.
Okay, any other question to other speakers?
Actually, it's a general question for all of you. Did somebody look at the data of the radionuclide data at the same time the seismic data to predict the seismic? As I mentioned, that some of the scientists now, they do the study to put detector at least, which is, they call it radon detectors. Now, the stations that's available is detect the natural isotopes. Is somebody just like, this is my questions to everybody, is like, if somebody's doing such a studies, or can,
May I try to answer the question? It's a very complicated question because the any earthquake prediction, as already mentioned here, assume it's the four major parameters. It's the magnitude, the place, it's the time, and the probability of occurrence of this event. And it's to understand where we are, we have to go to a specific place, and in this place you will have a one station probably nearby, not so many stations. However, there is a point is a little bit different. I fully agree that the implementation as much as possible data will be very important. However, again, today, neither of the precursors, which scientists established with, let's say, half a century, and they consider to be reliable, didn't show that they are reliable individually. For example, you mentioned radon. It is not much reliable in one places. In another places, sometimes reliable, sometimes not. But the point is that bringing this unique database of the IMS, it would be very important to really yes, exactly, to look how these parameters correlate close to the big events. That's very interesting to see. But again, there is I am not sure that it's all data can be used for this seismic hazard purposes.
For the earthquake prediction, it is just like suppose you go to the doctor for to the doctor for your disease detection. Doctor made ultrasound, everything. They know each and everything in every second in your body, but he cannot tell when the person will die. So our Earth is very complex and very huge. Unless you have a ultrasound every nanosecond of every layer of the Earth, you cannot say what will happening in the particular layer or particular place or particular time. So it is very complex. So it will take time, but time will come. We will able to predict earthquake reliably. Yes.
Thank you very much. Next question there comes.
Yes, thank you. Also a question to all those who have presented. I'm interested in what the steps look like when you actually want to use IMS data and IDC products. What are the steps involved from your first idea until you actually have the data on your hard drive, let's say?
Very good question. Who of 6 speakers would like to answer? Or maybe some people from CTBT. Yes, yeah.
So just to clarify, your question is about how to get IMS data and products to use in scientific studies. So the mechanism for that is the so-called Virtual Data Exploitation Center. Of course, national data centers have access to our data through other mechanisms, but research institutes can sign a zero-cost contract with the CTBTO and submit a proposal for the study they want to perform. We review this and then we provide access to the data via this VDEC mechanism. I would say that depending on there's a legal process involved in this and there's a non-disclosure agreement, and depending on the processes in place in the institution that requires access, that can take in the order of a few weeks to go through this process.
Thank you.
Further questions? I have a few questions actually to the speakers, if it's allowed. First to the Dr. Garces. Yes, you are here, I see. That was a very interesting presentation. How you can imagine how many stations you need to worldwide to get a really very reliable prediction of the, let's say, ash propagation? I mean, it's a permanent station and the mobile stations.
So it's a...
I mean, optimization problem.
Optimization
exactly.
problem. I think that it was touched upon. If you have a design specification, then you can answer that question well. So for the smaller eruptions, what we've learned is that it's harder to predict. For the bigger eruptions, it's actually easier, a little bit like earthquake damage. If it's a big earthquake, things are likely to collapse. If they're not, it depends on the construction standards. So let's say that if you're looking for a VEI4 type of eruption, that's our design specification. We know that the IMS can pick this up with up to 3 stations. It was 16 last time. So we know that we can do this. So the question is not whether you can pick it up or how dense, but how quickly you can pick it up. So it's not a race against intensity, it's a race against time. So how close do you need to be to get early warning? Well, it scales with the speed of sound. So part of the question is, what is your area of coverage? What is the acceptable time delay to get an early warning? And then you design around that. So we wish for 5, some people will settle for 15, and again, a few cell phones per region will be nice, but it's a huge playground, right? So if you try to instrument that at $10,000 a sensor, it gets very expensive very quickly. If you can do it in a very cost-effective way, given the probability of eruption, just like earthquakes, is unknown until, right, plus minus 100 years, then part of that's part of the design specification. This is why we're nailing down the VI4 within 4,000 kilometers, the VI4 being, the race against time versus the race against energy. So I know I didn't answer your question, but I addressed it at a deeper level, I hope. Yeah, thank you.
Yes, and it's with just a comment, it would be a very good idea to have such kind of the, the investigation, it's presented to the VASAC You know, it's a special group it's called the IUGG WMO, the advisory group, which is really advise the WMO immediately to inform people about this ash propagation and so on. That's really very important what you are doing.
Thank you.
Thank you very much. Any further question? I wouldn't like just to impose. If not, I have a question to Professor Rogers. She's here. You are here. Thank you very much. It was a wonderful presentation as well. And could you please tell, this is an acoustic signal which whales, which you collect data from their signal, which is a signal, acoustic signal. Again, it's probably based on the biological, where I am not expert, biological expert. How much the signals truly different between the different type of or classes of blue whales? Because it's just the same type of whales, but depending on the conditions, on behavior, and the clustering, their diapason is quite big, and they can produce a different, signals at different frequencies.
Yeah, that's a good question, because often the size of an animal will dictate the frequency at which they produce the sound. The actual structure of their calls are really different between the different populations, and along the migration routes as they move from, say, the Antarctic blue whales, they'll make the same type of sound in Antarctica as we hear off Samoa. So along their whole migration route from the high to the low latitudes, they're making that same kind of call. And the different ocean basins, you have these very different structure to the call, so different acoustic features. So it's not like a subtle change. They're completely different in not only their structure but also the frequency range. So some of them are up to about 28 hertz and have multiple bands, whereas, say, the Antarctic blue whale has a very simple sort of Z-shaped call at a much lower frequency.
It means along the trajectory, let's say 30 hertz is preserved along the trajectory, or along the trajectory of their movements, the frequency can be changed.
Yeah, so that the call stays the same, the same structure and the same frequency, the same shape. Okay. Through time, though, like the call actually, over the last 15 years, the frequency has been shifting down, and we don't know why, across all these different populations, but still the structure of the call remains the same, and the shift is only very, very small. And when you look at earthquakes, you're looking at onset envelopes, etc. So it's exactly the same with an animal call. These animals produce incredibly stylized calls, which is great for us, unlike other kinds of species like humpback whales that change their sound, the different kinds of calls they make all the time.
Thank you very much. Further questions? Yes, please. Yeah, that's the last one.
Thank you very much. I have a question for Professor. During your analysis, you said that you're using MS data, yeah? To identify between earthquake, a real earthquake under the ocean, and those sounds coming from the whales, how do you identify the T phase? Because we are talking about T phase and not H phase, because it's characteristic for explosion. But about T phases, how do you differentiate between T phase signal and the whole waveforms and the waveform typically for earthquake? Thank you.
Yeah, sure. So what we do is we're actually not looking at the waveform, where our algorithms are looking for specific frequencies. So where the different groups of the whales have more energy at specific frequencies. So we'll write an algorithm for each one of the different populations and look for the marker for that population. So for instance, the Antarctic blue whale has a tonal call, very tonal call, and depending on the year, because I was saying they shift through the years, we'll actually have to change our algorithms per year and then do tests to see how many we're missing and how many we're falsely detecting as well. Because sometimes sort of impulsive sounds or sounds can actually trick us and sound like a whale. So we actually have to do tests, and for it, that's what takes us so long. We had to have 2016 up there. But we have to go through and actually check and calibrate for each year because they shift their calls just slightly.
Thank you very much. We have to move to another part of our session, and this is a 1-minute presentation of posters, because we consider posters as another type of presentation. That's why it's not a second type. We will give a 1 minute to 8 presenters who already approached our colleagues here and gave a 1 slide. And I will call 3 first people. Please, could you come closer here? It's Kalinde Cafe, Amartey, and Nugraha. Nugraha. You are all here, no? Once more, Kalinde Cafe, Amartey, and Nugraha. You are first? Kalinde Cafe. Okay, great. Then it's please the next prepare to change.
After 50 seconds, we will hold this up so they know they just have 10 seconds because after a minute it will switch.
Okay, we will start the presentations. First, Kalinde Cafe, please. 1 minute presentation. I will show this one before 10 minutes.
Thank you. Thank you. Okay, for correction, I'm Felix Mpepo, not Kalinde Cafe. He's my friend. He's a professor at our University of Science and Technology, so we did the job together. Thank you. As I said, my name is Felix Mpepo. I'm from Geological Survey, Malawi. The poster depicts the work that I did with my friends in mapping active lineaments within Karonga area, northern part of Malawi, using automatic lineament extraction methods. This area is seismically active, and because of that, we decided to map the active lineaments or faults that are active to generate the seismic activity. So to achieve that, we used 2 data sets, the satellite data and the geophysical data. Okay, thank you.
Next one, Amartey. Please come closer because it takes time. Yeah, thank you. Next one, Nugraha, please, closer.
Hello, I'm Edmund Oko Amati from Ghana, National Data Center. And my other colleagues are Ruth Annan and then Emmanuel Termensa. Earthquake safety, an important contribution of CTBT, seismic monitoring data. Seismic monitoring data is one of the beneficial services the CTBTO offers to its state signatory for public good application in the area of earthquake safety for Ghana. This data is vital element in earthquake safety planning process. You are welcome to visit my poster stand. Thank you.
Thank you very much. Great. Next one is Nugraha. It's not present here. Mulva, please. Next one, Mulva. Next one will be Bisalallah. Bisallah. Next one. Yes, please.
Oh, no. It's not mine. Okay. Yeah, so good afternoon. My name is Josephat Mulwa. So my poster is entitled Seismotectonic Implications of May 20 or 20 May 1990 South Sudan earthquake. And the question is, why 1990 in the 21st century? This is the largest earthquake to occur in the eastern part of East Africa. The others have been historical earthquakes. So we performed a teleseismic body wave inversion. So the first diagram shows P and SH waveforms inversion, and then the second one shows P waveforms inversion. And we can see it's purely strike slip, not tensional, as opposed to other earthquakes in the rift. Welcome to my poster.
Thank you. Bisallah, next.
Thank you very much. My name is Awal Bisala from the Nigeria Atomic Energy Commission. Essentially, my work has to do with the Virtual Data Exploitation Center, which has immense potential to support the activities of the CTBTO within the West African subcontinent. We've noticed poor utilization of this platform, and so we decided to do some work in order to popularize the use of this platform within the African sub-region. That's the focus of the work, and you are invited to visit me. I'll be available to answer and discuss with you. Thank you.
Thank you very much. Next one, Al-Rashidi, and after, Mahdi.
Yes, good afternoon, everybody. My name is Dr. Mafra Rashidi from Kuwait Institute for Scientific Research. In this poster, we try to present the trend analysis of the cesium at RM40 station in Kuwait before and after Fukushima disasters. And as you see the trends here, the red one is after Fukushima, and the blue one is before the Fukushima disasters. And this is give us another questions for what just presented regarding the cesium, the beryllium-7 today in the sessions. And luckily, this station measured the high cesium concentration among all the AMS, all the RM station, particulate station in the IMS systems. And I wish you to come to the poster side to discuss more about the subject there. Welcome, everybody.
Thank you very much. Mahdi. Next one, Fernandez.
Thank you very much. I should have include the whole map for the 4 islands, but we're going to focus just on the Anjan Island. So with the complicated geographical and geological structure for our islands, we have been some problem or some issues, some natural issues have been raised during these 2024, 2014, and 2016 and 2015. So we raised, for example, landslide, earthquake, and volcanic activities. But in specific area of these islands, is between 17 days, between the 24 March 2014 and 29 March 2014, within 17 days. So we're trying to separate and to differentiate between these events, 2 events, and to conclude what is an earthquake or a landslide. But definitely, we have to be sure that there is some fault around the island, and we might consider them as a hazard. Thank you very much.
Thanks.
Please come to.
Fernandez. He's not. I received a list of the 8 speakers for their poster presentations. Nobody's missed because it's a much more, yeah, we have posters, but it was not, I think it's uploaded here. It is uploaded? Okay, then I have only 8 here. Ah, I see. Not received. I see. Yeah, we are very sorry, but it's according to procedure, it's not possible to accept right now. But we will all, you are all invited to the poster session after the short break, exactly half an hour. And then it's at 17:30. Please, everybody, come to the posters, and we will continue the poster session in the hall of Festsaal, which is a main hall here. Thank you. Thank you very much to our speakers and to all who attended this session, oral session. Thank you.
sitting down anyway. This is supposedly a workshop, not a formal presentation. You'll be happy to know I don't have any slides. Okay, so. Thank you.
Machen Sie mit, Herr Schulze? Doch, bitte. Schön. Bitte, danke schön. Das ist nett. Danke sehr. So, it's a rather odd time slot, so I apologize for the late hour, and I'm happy that people are here anyway. So I'm very happy to introduce Peter Rickwood of the Atomic Reporters. I think I've introduced him already in the orientation session, but not all of you were in the youth orientation session. But the title of the workshop is Effective Communication Skills, and I think we've heard a lot about the importance of communication over the last 2 days. At the end of the day, if we don't tell the message of what we're supposed to be doing here and how well we are at doing it, then people won't know what we're doing, and politicians won't feel the need to push for entry into force or help fund the organization or anything like that. So it is very, very important. The reason Peter Rickwood is doing this workshop is twofold. A, because he's a veteran communicator, and I'm very, very grateful for his support. But also because he is running our youth newsroom project, which is going to be, or has been covering the conference for the past day and a half, and will continue to cover the conference. So he'll be speaking a little bit about that, and also about the organization he runs known as Atomic Reporters. So without taking too much of your thunder away, Peter, I'll hand over to you. Thank you so much.
I think at this time of the day there's probably not much thunder left, but thank you very much, Elizabeth, and a pleasure working with Elizabeth and the CTBTO again. Look, you know, what is effective communication? Well, I've got some really interesting comments to make here. And this was a list of the most effective, what can you call them? You know, headlines of interest that social media has used. It was compiled by BuzzFeed, and it gives you some idea what works today. So, if you use the term "will make you," you're gonna get a lot of interest. If you use the term "this is why," you get less interest. If you use the term "can we guess," and these are all headlines. This is a compilation of headlines that BuzzFeed has put together. So I can send you the link afterwards if you're interested. But this is clickbait as well. I mean, you know what gets people using social media. We know the more and more people are using social media. What gets people interested? Well, X, stunning photos. Okay, that interestingly is way down from "will make you." Okay, makes you cry, gives you goosebumps. Talking about it, it's too cute. Shocked to see, melt your heart. X things only. So I'm not going to go through the whole list because it gets kind of tedious. But you've kind of got the idea that in an era when we're using, or when we're so dependent on social media for as a means of communicating, there were beginning to emerge certain standards, some formulae that work, but that doesn't go to the nub of what we're trying to deal with here, which is a bit more serious. However, I think we have to keep that in the back of our minds, that there's a need, as I keep stressing to people who are working with the newsroom group, that they have to be really, really hard-hitting, precise, concise. Attention spans are limited. People are not going to spend, a lot of time at first. But if you can grab attention, if you can appeal to something emotional, to something basic, then I think you have a chance of winning your audience over, which of course is important. Effective communication. I work with journalists. I think I'll tell you a little something about the work I do, because it also goes to the heart of what perhaps I can best inform you about in terms of communication. We are attempting to inform in order to encourage inquiry about nuclear science and technology. Atomic Reporters is a Canadian nonprofit which was founded 3 years ago. It owes its roots to my experience as a journalist slash press, well, I was no longer a journalist, and I was a press officer in the IAEA during the run-up to the Iraq War in 2003. That was a very, very, very sad day for journalism, for media coverage. There was a process where there was effective communication, but it was false communication. And journalists, I'm afraid in the main, swallowed the information hook, line, and sinker. And a mixture of metaphors, like lemmings, they went over the cliff. There were very few journalists who challenged the claims about weapons of mass destruction in Iraq and the resumption by Saddam Hussein of a clandestine weapons program. Now, we've seen the consequences of that information, being misused. And out of that, as a journalist working in an international organization at a time of great stress and crisis, I obviously was concerned for the practitioners of the craft that I had learned and had practiced. And so it seemed to me and other people who were, who worked with me, that we need to try to better inform journalists, because journalists are a bridge to the public. Their audiences, if you're not a journalist, are people who, again, would be following social media, but social media is using information which has to be created by someone somewhere. So it's absolutely vital that that information is correct, particularly now when the tensions internationally are as acute as they are. So what we try to do is to encourage journalists and nuclear specialists to sit down together and to exchange information. Because as someone pointed out earlier today, when we communicate, our communication is, of course, partly verbal, but it's also visceral as well. It's also, our looking at each other, our eyes making contact, being in touch with each other. The what do you want to call it? The animal side of our beings. Building trust, belief. So it's very important to have an exchange where the journalists, and it's a two-way process, where the journalists and the specialists can understand each other. That way you're creating an open channel for information to be exchanged more effectively than if I'm standing up there talking down to you and saying, now listen to me, I have something to tell you, I know more than you. It's not going to work, obviously. So this is the basis for our, I said the basis, this is our modus operandi. We also try to provide information that is actionable. And I think these are some of the elements of what is effective communication. I've also forgotten one really critical part of effective communication, and can anyone tell me what it is? It's the ability to listen. Listening is part of very, very much a part of effective communication. So if you want to provide, solid information, I'll call it data for want of a better term, particularly about nuclear science and technologies, then you have first to establish, this basis of trust to be effective. But you also, of course, and this is something that we are experimenting with now with the youth group newsroom project, we have to provide information that is actionable. Because you sit in front of a television and the information comes in, but what are you doing? Are you going outside and making use of this information? Are you affecting change? Is it changing you? Probably not. So what we try to do is to create circumstances in which the information we are providing can be used. So in the case of the youth group newsroom project, I am simply, and my colleague Alex Nietzsche, who's sitting in the back here, is simply helping newsroom group members find better ways of communicating. Back to the subject of this presentation, effective communication. How do you reach people? I'm working with Salwa, who's sitting back here. How can we provide information that makes a difference? Because we're talking now, of course, about attempting to provide support for the entry into force of the test ban treaty. We need to create context, offer context, why it is so important, particularly at this juncture in history. What can we do to encourage people who are the consumers of information to feel that they can make a difference? And I'm going to put this question to all of you. I mean, as children we grow up and we learn at school. That's pretty basic. But when we become adults, how can we, because I think the decision has to be, a collective response from all of us. How can we make a difference in the sense of using information that we've received? We do need information to begin making a difference. I go back to Iraq. Journalists didn't understand, the nuclear file. They didn't know much about, nuclear technologies. Had no idea what the fuel cycle was, what's a centrifuge, what's conversion, what's highly enriched uranium, and on and on and on and on and on. If you'd had some of those possibly, tedious, boring, factoids, maybe someone would finally have said, wait a minute, this doesn't add up. I don't think this is right. So today we call it fact checking. We have too many terms, I think, for some sort of, fundamental needs. But let me come back to how you think, information, providing information can make a difference. Does anyone want to give me their ideas? Because I'd really like to hear them. Please.
Yeah? Yep. I would like to speak about the experience of Chernobyl explosion in 1886. At that time, I was a student in Kyiv, Ukraine, So we have no information, no official information, till the 5th of March. Even the explosion happens on the 26th of April. In this case, information could save not only some lives, but also a lot of health of plenty of people.
Thank you. This is a really important point because of the CTBTO, if there was a similar event today, that information would be immediately available. And so I think this is, you're from Ukraine, or you were living in Ukraine at the time, or Belarus. Yeah, understand. So here's one solution. We need the further development of technologies like the verification system that the CTBT possesses, because it offers incontestable. Well, I guess you can always contest everything, but it's pretty hard to contest radionuclides that you've gathered in an air sampler. I mean, that really is a smoking gun. So one solution. I think the other solution, of course, is having a community of citizens or communities of citizens who understand some of these issues. One of the problems with nuclear technology in general is that because of its origins, certainly 20th century development of nuclear power, nuclear weapons, in military programs, all the information was classified. It wasn't as if someone was saying, "Hey, come on in and look at how we make nuclear weapons. Here's some plutonium." I mean, you wouldn't want to get too close to it anyway. But it's always been locked away in a cave, if you like. And for me, it's particularly frustrating that the information continues to be siloed. That it doesn't. We talk to each other, okay? I mean, here we are in this meeting. We're all, well, thank goodness for the youth group, thank goodness for young people like yourselves, because I hope that you're gaining more knowledge from coming to an event like this, and good for the CTBTO for inviting young people, because this is important. But we have to spread the word. It's not that in my little organization we're saying we have to ban nuclear weapons. We simply want to inform people about the technologies, the dangers, and have people who are empowered to make their own decisions. I mean, the preposterous side of all of this for me is that here we have the ability to blow ourselves to smithereens, but we blithely go on as if there's no threat, no problem. Yeah, we've got climate change, we've got too much to worry about, and I have to pay the mortgage every month, or I have to study for my next exam, or I have to. We're always focused on more domestic issues, which of course is particularly understandable, but we don't focus on something which could end our life on Earth, certainly. I think because we don't understand it. Effective communication. What do we do? Anyone have any suggestions as to more suggestions? Because I found your Chernobyl piece was fascinating. More suggestions as to steps we can take to be effective. Any ideas? What goes through your head? What's the first thing you think of? Would you talk at home with your parents about nuclear threats and dangers and the need for the CTBT? Is it something you would discuss? You want to tell me? Where are you from, by the way?
My name is Farnaz Alamari. I'm from the I was raised in the United States, but I'm from Iran originally.
Okay.
I don't think it's something that I would necessarily speak with my parents about on like a normal day. I think if they asked me about it, I would share it with them. And I think that resonates with a lot of Americans, like day-to-day Americans. If you're just on a bus, they're not getting talking to the person next to you. You're probably not going to bring up nuclear weapons. It's not a light topic to talk about. And I think in America, there's also this idea that, we have, the military is going to take care of it. They're going to be fine. We haven't had any accidents, and I think that's something that might be shared more effectively, because we have had a lot of, we've had trainings with like airplanes flying across loaded with nuclear weapons, and people didn't know about it until afterwards. I think that kind of stuff should be shared so people realize that even with a country with a great military, that accidents can happen or mistakes can be made, and this is an issue that affects everyone, and it just takes one moment of someone not paying attention for something bad to happen. So maybe that answers your
You're
question.
here. Obviously, you made the effort to get you and take part in this conference. I mean, what was the turning point? When did you decide you wanted to support the CTBT, that you were concerned about nuclear weapons? What happened to you?
Oh, well, it's a heavy question. I started studying politics in undergrad, and during that time was when they were having the negotiations with Iran. It was before the JCPOA. It was, I think, just the JPOA.
JCPOA.
But even before that, it was just the initial talks. And a lot of people were asking me, oh, this is your country, right? And you tell me more about it. And I didn't know, so I went in and investigated myself and figured it out. And then I got my master's in non-proliferation, and that's why I'm interested in the CTBT.
Okay, so you've given a lot of focus to the whole issue of non-proliferation.
Yes.
I'm going to ask you another question, and that is where do you live in the States?
Washington, D.C.
Boston?
Washington, D.C.
Washington, okay, so D.C. is D.C. But if you lived in a small town in somewhere behind you, right? If you lived in a small town, say in Pennsylvania, I'm thinking Westchester, for example,
sure.
And you wanted to communicate your concerns to local people. Okay, the person who ran the barber shop, the guy who runs the dry cleaners, the person who's running the muffler shop, whatever. I mean, how do you reach them?
I guess it's a little difficult for me to put myself in that position because I haven't been raised in a small town, but I would try to approach it by asking them about their experience, and because I think nuclear weapons are a deep part of the American experience. At least someone has like some kind of connection, the history, and ask them what they know about it, and then share my own experience. That's proven effective for me, asking questions and then sharing what I know.
I think that's all you can do, and I think that possibly is the way we have to begin. And I'm talking of effective communication. Get back to my subject, of course. I'm reminded of the 80s when effective communication, if you like, led to a very strong protest movement against nuclear weapons. Toronto, where I'm from, and we even got a couple of 100,000 people out on the streets, which is amazing. New York had 1 million people. Everyone was afraid. Everyone was this was the end of the Cold War. But I'm reminded of this because I was with a friend the other day who at that point in time, a little bit after that late 80s time, was the negotiator for START 1 on the Soviet side. He's now a scholar in residence in the U.S. But and it's not news I want to share with you, but he is pretty clear on what current tensions and what the dangers are, and his comment: we need to start fearing nuclear war again. So it's back to this is a sober, analytical mind who is hugely knowledgeable about risks and dangers from the broadest international perspective. So in the 80s, of course, none of you are old enough to remember this, but there was one of the turning points was effective communication, and it was a TV docudrama called The Day After, and it's always been credited. In fact, Reagan talks about it in his autobiography. It was one of the turning points for him in terms of coming to acknowledge the dangers of nuclear weapons and at that time, of course. And then, of course, it was followed by Reykjavik, which tragically was a bridge too far, but nevertheless was a remarkable achievement. So now, we can probably be accused of hysteria, or we would be, or in today's increasingly nationalistic environment, probably accused of being I don't know if the word traitor would be used, but it would be presumed, I think, by some people to be unpatriotic. So what do we do? Any more ideas? Because you're the people who've got the mess to sort out. Thank you.
So I think it's quite important to simplify sometimes these technical aspects. So for example, I remember when I was learning about the CTBT or nuclear weapons, a piece of John Oliver's last week tonight, and he made it comical. So for example, he listed the fun facts of nuclear weapons. And they say, for example, nuclear weapons are the most dangerous things on Earth. Then the United States has lots of them. Then some are controlled by floppy disks, literally floppy disks. And then you probably wouldn't trust the people in charge of them because of what they were doing. And then we've kind of sort of accidentally nearly dropped them on ourselves a few times. And no one seems to care about. And then once again, they're the most dangerous things on Earth. So I think if you put a comical aspect into it, it attracts people, and simplification on the message is quite also a Minute Earth video that was just recently published. I think that engagement in social media can be a good exposure for learning about the facts.
I just grabbed the mic off Peter, and I'm so happy you mentioned Minute Earth, because that's exactly the point. We've done 2 short cartoons about the work of the CTBTO, one that we published at SnT 2015, that's on our YouTube channel, and one that was just released last week on Minute Earth. And they're tiny little cartoons, they're 3 minutes long, and the guys who do these have done an absolutely fabulous job to be technically accurate, which is what Peter was referring to, and entertaining. And to tell, I've been doing this job for 3 years. There's people who've been doing this for much, much longer. I find it very hard to explain what we do in 3 minutes, but they pulled it off, and in a visually entertaining way. And to me, this is brilliant. This is what I think all of us who do science communications aspire to. So the only credit I can take is that I found them and said, yes, let's do one of these. So. But thank you for mentioning that.
Yeah, your remarks were valuable. Thank you very much. And I think let's we're not over yet, but let's look at this on a positive note. And I think we have a wealth of communication platforms now. People I think, you know, since the 50s, or, you know, a less, I'd say this with a mixture, it may get a mixed response, a less respectful. I think people are able to be more critical and are going to say, we have to be given this information. You do have an accountability that has to be met. At the end of the week, you're going to be listening to Des Brown, who used to be a UK defense minister, and he always insists that, you know, that countries that have nuclear weapons should be informing people about what the heck the damn things will do. Because you saw the Grenfell fire in London. Well, imagine, you know, 10,000 fires like that in a city of that size. It's not a pretty picture. So we don't want to scare people. I used to be an environment reporter. I was a science reporter, so I wrote about, you know, the beginning of climate change and toxics in the environment. And there was always that balance that you had to strike between, you know, numbing people, you know, by creating so much fear. And then I think it comes back to what I was saying before, actionable information based on, you know, very solid, very, very robust information, and it's out there. But do you know where to look to find out how many nuclear weapons there are, for example, in the world's arsenals? Maybe you do if you're more interested in the subject. But if you're a journalist, it's more difficult. Where do you go? So one of the propositions, and I'm not, this isn't a paid commercial, but one of the propositions that we're working on now is providing what we call toolkits for journalists, so that you can immediately get that information without going through 100, you know, websites, Federation of American Scientists, you know, well, and you know, a number of non-proliferation organizations like that. So, and then we come back to you and you and you and you and you. I mean, people, you know, there was a comment by Bill Potter in the panel discussion today about, you know, why isn't this information provided in schools? Again, it's not to frighten people, but it has to be an acknowledgement. It's almost as if we you know, looking at the issue from the perspective of a flat earther. It has to be resolved somehow, and if it isn't, you know, I don't think there's much argument that the odds increasingly are on something that what you were mentioning that would go wrong, or an active hostility. I always say, well, yes, you know, there've been a number of civilizations and societies, but they didn't have nuclear weapons. You know, there's less forgiveness. I think that people can. Oh, please.
Thank you. I had this thought about schools also when you just mentioned today, because for a long time I had opinion when I was reading and educating myself about nuclear weapons or anything related to this topic. Is always somehow I have a feeling that it's something that I self-taught. Like I'm finishing a PhD and I don't really remember that. So many times in my school I heard about nuclear weapons. So I had for a long time this thought. But I think that one of the ways that this could be somehow handled is to the children nowadays. We have to understand that most of the time they don't just go to school and learn stuff, but the children nowadays are using very much internet. They're researching, they're educating also themselves. It's much different way of education than it was when we were in school, or me even. So I think that it would be good to somehow find a way to make this information about the topic more available on the internet, on some online space, in a way that is very educative also to the children. So, because I think that this civic engagement is very important for this topic as well. And somehow, if you would educate these people from a very young stage, in some near future, we would see much higher awareness of the topic. So, yeah.
Now I have two microphones, I'll be speaking in stereo. I agree completely. I think it's a necessary step. And I think that there were small steps that, as individuals, we can take. Just writing letters to editors, although there are a shrinking number of newspapers now, so that's getting to be a problem as well. But we don't have to, go to the mountaintop and, proclaim whatever our concerns are. I guess it was a 60s term, you think locally, act globally. Yeah, no, it sort of brings it back. But it's still valid. It's still true, because you can't make dramatic changes. You can't change a government. Well, you can by voting, obviously. But I mean, in the meantime, you can keep your fellow citizens informed. Find the most reliable means of sources of information. They most certainly exist. Despite the classification of information, there's more than 70 years of data about nuclear technologies and nuclear weapons, and an awful lot of people out there who would support any effort. I mean, you have to do it on a shoestring. I mean, you're not probably going to get a local initiative grant, but I think if you start the conversation, and the point of the conversation comes back to the treaty, which is there are means of addressing the dangers, the threats, and the risks, which we haven't, adopted. So it's not as if you're saying, "Oh, the sky is falling, the sky is falling." You are actually saying there are solutions, there are means to address the dangers. We have to, just out of very selfish, need for our survival. So, do I hear any more questions from the floor? Or because I think everyone by now must be tired. It's the end of a long day. I really appreciate your listening to me. And oh dear, people are coming in, and now I'm going to be going. But I can give you a custom version. If I don't hear any more questions, if anyone has any other comment, please, because I do find this is more valuable than listening to myself.
I just want to mention this because I think nobody has talked about this. I think it's something that is very important is to use the simplest language we have, like the simplest word that your grandma, your neighbor, your nephews can understand. And this is especially important in science communication or communicating things like the CTBTO to all the public. And this is based on an experience I have when I was talking about this in my school. And I was mentioning the phrase entry into force. That for us is very common. All people engaged in the CTBTO knows what does it mean. But all the people in my school was, what do you mean by entry into force? We never use that phrase. We don't know what does it mean. It's something very simple. And I try to explain what does it mean entry into force. I just say it's the enforcement of the treaty, that everybody agrees with it, is going to enter into force. That's what it means. And I think that's something very important, that we should use the simplest words we have.
I thank you for that contribution, because I think it's really, really important. We tend to get locked into jargon and technical terms which no one else understands, and yes, everyday language. We have to kind of create a parallel of, vocabulary that we use. Please.
I guess just an observation I had when talking to people about the CTBT is, oh, we don't already have that. It's not something that's already, in force. So I think it's something that is assumed that is already ongoing, at least with the general public that I've engaged with. And I guess by having that discussion, therefore you expand their minds and you allow them to know that no, it's it's not actually entering into force quite yet, and we need to do more. But what would you do to kind of remedy that? Because I think that a lot of people just assume these things, you know, they're already protected. You know, we're not testing nuclear weapons anymore. What would you say to that? How would you kind of remedy that? Because it's really hard to kind of fix something when you don't know. It's the unknown unknowns and known unknowns.
Yeah, uncertainty, of course, is the sort of nature of science anyway. But we're talking now, though, about something other than science per se. I think that people have to understand the context, which is that the treaty was open for signature 20 years ago. Today, at a different time, when the dangers then seems to be subsiding, today the dangers are rising again. No one is talking. There was nothing like the CTBT happening. There was no arms control conversation of any substance. It's simply the two sides, you know, saying you didn't do it, you didn't do it, you didn't do it, you didn't do it. I think if people understand the dangers inherent, I was telling you about my Russian friend. Then because it has to be, it's not once the treaty by itself, people may not understand it. But if you explain to them that the treaty is the sort of the medicine for the disease, and the dose isn't being administered as it should be, because the treaty has not yet become law. That's basically what it is. And there were other steps that have to be taken, but the treaty is the first step. And so it's people are concerned about climate change. I think there's recent polls I've been seeing from the U.S. A lot of people acknowledge it because there's been an awful lot of publicity given to the subject. The problem with nuclear is that now I'm got my journalist hat back on. If I want to go to my editor and say I want to write a story about it, the editor says, well, no one's dead. When were the last people who died from nuclear? Oh, 1945. Forget it. It's a difficult subject. I'm not saying it isn't, but it's respecting the public by sharing information with them much better than unfortunately our news media is able to do, or has been able to do. And I mean, I criticize the newspapers I worked for, but there has to be this informed, broad conversation. Then the CTBT makes inherent sense. I mean, it doesn't make sense if it's just sort of sitting out there. Well, why wasn't it signed? Well, it doesn't make much difference. You've got something more or less in effect. But I think there's obviously the entry into force, or it becoming law would be hugely symbolic at a time when I think there is acknowledgement that the dangers are rising, that the risks are not going away. So it's a long process. It's not one conversation, it's many conversations, and that's why I think it's important that you keep, it's a reiteration, and it's a discussion. What do you just ask people, as I'm asking you, what do you do? What can you do? We have to, is it a problem? Oh, I don't think it's a problem. Nothing's happened, nothing could go wrong. Well, are you very happy with your computer? I mean, have you had any problems with your computer recently? Yeah, right, of course, You think things don't malfunction? Do people, not get angry and crazy with each other? Can we trust our leaders, regardless of who, our leaders are? It's trying to get people to think like adults, and not just about themselves. Although they should think about themselves in terms of the dangers from nuclear. Not a very satisfactory answer, but anyway. It's movement, work, conversation, information. You just can't stop.
Thank you.
Any other comments? Then it's time to, oh, good.
Sorry, sir.
I'll stay here as long as you want to stay here.
So one thing I think is with the rise of social media now, in the aftermath of a big event, whether it's a fire or an earthquake, a terrorist attack or a nuclear test, people now just go on social media to find out what's happening. So people are going there with their comments, their observations, their knowledge if they have it, or mostly just rampant speculation. And I think even journalists go onto Twitter to find out what's happening in a breaking story because nobody knows. And I think it's valuable, therefore, for scientists or experts of any sort to go on to those platforms and make considered information available to the public because the public will read it. So in the aftermath, for instance, of the fire in London, there was a residents group of that building who had been campaigning for years about the fire safety, and they went on to social media to explain that they had told the people in charge of the building that it was not adequate, and now that's all come to light, and it looks like in the UK at least, laws will have to change to make sure this never happens again. So the same thing applies whatever the emergency or the event. If experts make information available, people will find it, and that's how it can reach a wider audience. And if they don't make the information available, then misinformation will spread because people who don't know what they're talking about won't waste any time in taking to Twitter to make their voices heard.
The only difference with nuclear, of course, is that if ever one of these damn things exploded, it would not be quite as
Sure.
a small scale.
Well, I think
that's what we're trying to avoid,
yeah,
obviously.
rather than a nuclear detonation, perhaps. I mean, like, North Korea are bound to do another test. And when, basically, rather than if they do detonate another test or successfully test a rocket, people will start talking about it. And in order to keep their speculation under control, experts like there are here should say, well, is this event larger than previous ones? Is this event, like, what does it mean? And filling the internet with considered facts rather than speculation. So you're right, if there was an actual nuclear attack, we'd have bigger problems. But as there's very likely to be another nuclear test reasonably soon, there's still an important job to be done.
I think you have a very good point because from what I can see, the public trusts scientists more than it does journalists. And I think for good reason. I mean, I don't have a great deal of respect for journalists myself, even though I am one. But how do we encourage journalists then to communicate the information? There's a lot of journalists who are involved with nuclear technologies may be very cautious. By the way, what is your background?
So I'm a PhD student and I'm a forensic seismologist. So looking at what I know, there are people who are at this conference who, in the aftermath of previous North Korean nuclear tests, have gone on Twitter or Facebook to post data about them and to explain what's going on in scientific terms. So that's what I was thinking of with that. But yeah.
Yeah, and that's very, very, very encouraging. And you know, if more and more of that happens, I think it's really important. I think at the moment we're going through a communication revolution, and it's messy, and you know, it's not quite clear what's going to emerge. But if science can take advantage of the social media phenomena, then you know, I think that's really a positive step.
I think journalists will listen, because if something gets amplified enough, I think journalists you probably know this yourself, journalists, well, they seem nowadays to like when people do their job for them. So if something becomes viral enough on Twitter, they will see it and they'll be able to report on it. And then increasingly we see comments made on Twitter enter into mainstream media because they've been retweeted enough times that journalists take notice. So I think that will happen whatever.
And the simple fact is, when I was a journalist, I didn't have all the knowledge of toxicology when I was writing. I was totally dependent on science. I mean that. Any journalist is only as good as her or his sources. Thank you. Any more comments, questions? Oh, thank you.
Okay. So what I feel is that as much as we like to try to tell people about the CTBT, and some people listen but some people don't, what I feel is that people don't really care until it threatens their own lives. So like, how can we let people know that without this, that's it. It's the end of the world as we know it. Yeah.
It's a good point, but I think part of the communication process has to involve recitation of history, because an awful lot of what we're living through now seems to be a repetition of history. A lot of people, and I don't mean this in any critical sense. Your generation, for example, didn't live through the history of the post-World War II Cold War era, so you could not be expected to have a sense of the fears that people had at that time, when there was the Cuban Missile Crisis, or when there was really strong tensions between the two sides. Well, the argument is that those tensions have come back again, and so we need to blow the dust off some of that information and inform ourselves and point out that the CTBT is unfinished business, because it really is. It came into being at the end of the Cold War. It was going to be a step on the road that would lead to disarmament, and we just our vehicle fell off the road into the ditch or something. But the proposition that we use humor, that we use any tool we can to provide the information. There's a proposal in the youth group for a rap presentation, which is a video rap, which I think is sort of cool. So you simply have to pull that information into whatever you're dealing with now. I mean, you're not going to, obviously, not your whole life isn't going to be focused on the nuclear threat, but when you do, get engaged with the issue, I think that you have to acknowledge what's gone before, what the CTBT is about, unfinished business. Please, Salva, can I have the microphone? Oh, you could have had mine.
But possibly also apart from acknowledging that it's unfinished business, like my thinking would be kind of stress the way it's also useful in the other sphere. So, kind of not just saying, of course, we have to finish what we started, but I would feel also it's always good to say, look, like it's actually serving us already. Did you know that thanks to the system we've been able to trace climate change, and we know that there's some melting of icebergs out there, or it can help us with the earthquakes, and actually on the larger scale, because people kind of feeling that there is something personal, that it gives a little bonus to them. That's what people are usually interested in, not exactly what you were saying, not about the global issues, but something that might be global, but you feel it locally. So it's really good to kind of play around this, saying it's actually there, and it gives us something, but we have to be there also to support it, to make sure that it can give an even bigger result.
And personally, are you following that course? Are you taking that path?
Well, what I've experienced, because I have recently joined the CTBTO, was when speaking to people around me, for example, family members or former colleagues, almost everyone would have a story to tell me that would be in a way related to, let's say, either how they learned about nuclear testing, or, for example, some school experiences when in Germany in the 1970s or 80s, where they had those mock nuclear test sessions when the bell would ring and everyone would have to run. So what actually surprised me was how easily people could relate to the cause. So, you know, when you start telling them, I work for this cause now, immediately there is some kind of an interest, respect. And I think this is the platform you should build on, because interest and respect can, I think, if you follow up on it, actually lead further on to action. But this is exactly when I think what all of you can contribute to is by taking this action to make sure that you seize the momentum, and it's not only like, wow, like, we're a member of this fantastic youth group, we've done this and that, it's so interesting. It's more about saying, and by doing this, we can actually contribute if we do it together.
Thank you. No, I think that's a great rallying call that we should get behind. Do it together. I mean, maybe it's only 3 people or 5 people or 6 people or 7 people, but I really think it's important. Thank you. Any more? Shall we take the rest of the day off? You think? No, it's too early. Let's just stay here another 2 hours. I want to thank everybody very, very much for coming again, and please consider that you are all potentially activists, but it has to be done with you know, intelligence and respect and measure, please.
Yeah, I think it's a little late, but I think in terms of communication, what is important is knowing the audience, the target audience, and after that, it's to inspire them. I mean, in daily life, of course, people care about, you know, seeing their friends or, you know, eating food and take a picture from it with a specific hashtag and share it on Facebook than a nuclear weapon, I think. But we have to see how we can make this nuclear stuff as a trend. I think we never try to, you know, take out a trend out of knowledge. We always like, I mean, maybe it's because related to marketing and stuff, so the scientists, people don't care about this kind of things. But I think nowadays, if we want to communicate it, the nuclear weapon is a huge piece of food, and we have to, you know, slice it to a small piece and feed people. And I don't know how is that possible. It's not easy, of course, because maybe we don't know the target audience, or maybe they're too much. They're, you know, whole people all around the world. But we have to see what they want to hear. I don't know, by the conference like this, by the campaigns, or by influencer marketing, or these kind of things could be very effective, I think, in terms of communication. So, yeah, that was my idea, which one.
Oh, it's fantastic.
Yeah.
So, again, we can reach out at arm's length to just the people around us as well.
Yeah.
We have to begin. But the cool thing I'm hearing from this room is that everyone is a potential activist. And I told you I worked as an environmental reporter, and I did see individuals make a huge difference. I cannot, you know, ever forget that. So everybody can make a difference. There's no question. Okay, thank you.